So hello, my colleagues, and we left off here, okay, about the price sensitivity of yield to maturity, and we were talking about time, right? So here's the yield to maturity changing for a zero coupon bond and for a 10% corporate annual coupon bond. So I want to play this video for you. It's 6 minutes long, but it's really valuable. So let's run this.
Sensitivity of bonds. So in this problem, we're considering two bonds, a 10-year coupon bond and a 30-year coupon bond. They have the same coupons, 10% coupons paid annually, and we want to know by what percentage will the price of each bond change if its yield to maturity increases from 5%. So they have the same annual cash flows, and they have the same payoff at maturity, and one of them just happens to be a longer maturity bond than the other, and we want to see how does that actually affect how their price changes when interest rates change. So let's think about the cash flows from these bonds. So we have per $100 in par value, each one is going to pay $10 a year in coupon payments, and then at maturity, the 10-year bond will also pay the $100 in face value. The 30-year bond will still pay the $10. It keeps going all the way to year 30, at which point it will pay the $100 in face value. So what we have to do is figure out how we're going to price these bonds, and we'll price them at a 5% yield to maturity and a 6% yield to maturity. To do that, we're going to use equation 6.3, which gives us the price of the bond as a function of its coupons, yield to maturity, and the face value repayment at the end. This equation recognizes that this part here, the coupon part of the bond, is just an annuity, and that captures that in this part of the equation, which is just the formula for an annuity. And then it just treats that last payment of the face value at the end as a separate future value to be calculated, for whose present value can be calculated separately. So what is the coupon? 10. The yield to maturity, we're going to put in 5%, and then we'll recompute it at 6%. N is going to be the number of payments here, the number of years left to maturity, so that's going to be 10 for the 10-year bond and 30 for the 30-year bond. Face value down here is going to be 100. Again, we'll put in 5% and 6%, and then it's 10 years to maturity. If you look at the problem, we've already gone through and done that for each of these. And so for a 5% yield to maturity, the 10-year 10% coupon bond, $10 coupons, 5% yield to maturity, 10 years, $100 repaid at the end, is worth $138.61 per $100 in face value. If the yield to maturity goes to 6%, then its price drops to $129.44. Right? Remember that as interest rates go up, bond prices go down because interest rates represent your opportunity cost of investing in the bond. For the 30-year bond, at 5% yield to maturity, it's worth $176.86 per $100 of par value. And if the yield to maturity goes to 6%, its price drops down to $155.06. Notice that in all cases the bonds are trading at a premium. That is, their price is greater than their par value. And that's because they're offering coupon of 10%, where yield to maturities are less than that. Now, you can see just eyeballing this, and we can calculate out the percentages, that the change in yield to maturities has a much bigger impact on the 30-year bond than it does on the 10-year bond. It drives both prices down, but it's a much bigger deal for the 30-year bond. And if you actually calculate this out, the change 129.44 minus 138.61 over 138.61 works out to be a decrease of 6.6%. And the same calculation for the 30-year bond gets you to 155.06 minus 176.86 over 176.86, and that's actually a 12.3% decrease. So it's almost double. It's almost twice as sensitive. The 30-year bond is almost twice as sensitive to interest rate changes as the 10-year bond. So let's go down to the evaluate section and think about what's going on here. If we actually graph the change in their price, graph their price as a function of the yield to maturity, the slope is how much the price changes for a change in the yield to maturity, you can see that the line for the 30-year bond is steeper than the line for the 10-year bond, reflecting its greater sensitivity to changes in interest rates. And that's because the change in the interest rate is going to compound out over the life of the bond. So that 1% change in the interest rate from 5 to 6% gets compounded over 30 years for the 30-year bond and has a much bigger effect on its price than it does on the 10-year bond. If you could think about this in another way, think about it in the extreme. Think about a bond that matures tomorrow. If the interest rates change, it doesn't really matter to you. The bond matures tomorrow. There's not enough time for the interest rate to matter. And so the closer you are to when the bond is actually going to mature, the less sensitive it is to changes in interest rates.
All right, so that was a good video there, supplied by the publisher. So in actuality, bond prices are subject, and this is important, to the effects of both time and changes in interest rates. Okay, so bond prices do, as we know, they converge to the face value due to time effect, but also move up and down due to unpredictable changes in bond yields. So if you look at figure 6.2, this illustrates this behavior by demonstrating how the price of the 30-year zero coupon bond might change over its life. Note that the bond price tends to converge to the face value as we get closer to the maturity date, but also moves higher when its yield falls and lower when its yield rises. So let's look at figure 6.2. So look, here's 6.2. Yield to maturity and bond prices are fluctuating over time. So here's the year, right? And here is the fluctuation over time. Okay. So these graphs illustrate the changes in price and yield for a 30-year zero coupon bond over its life. So the top graph illustrates the change in the bond's yield to maturity over its life. In the bottom graph, the actual bond price is shown in blue. Okay, so this is kind of superimposed on here. Okay, because the yield to maturity does not remain. So here's the yield to maturity changing. So that's affecting the bond price here. Everyone see that? They're coupled. The actual bond price is shown in blue here. Because the yield to maturity does not remain constant over the bond's life, the bond's price fluctuates as it converges to the face value over time. So you can see it go converging to the face value. This is for a zero coupon bond, all right? And they have basically some graphs here. If the yield remained fixed, right, you wouldn't get that noise. Alrighty, so I will pick up here. Or better yet, I tell you what, I'll keep going, just because there's a concept check here. So as this demonstrates, prior to maturity, right, the bond is exposed to interest rate risk, as we all know by now. So if an investor chooses to sell and the bond's yield to maturity has decreased, then the investor will receive a high price and earn a higher return. And this is all due to the inverse relationship between interest rates and bond prices. All right, so I think let me move on. All right, so I will pick up here next time. All right, and this is an interesting thing. People have asked me questions about who went ahead about bond arbitrage, and we'll discuss this. All righty.